in the morning on Wednesday and try to have a good title. Okay, I try to have a good title, but don't expect too much because I'm certainly not a visualization expert. And that's why also at the beginning, I want to acknowledge actually Kyla Vaughan, who's actually a visualization expert here at the university, and he had some slides with me. I tried to get him instead of me, but he couldn't come on short notice. And Lazaro for helping me with all kind of visualizations with Julia, which is usually a lot of fun. Yeah, so let's see how that works. I'm pretty courageous that I will also try to do some live things in Julia. Let's see how it works. But basically, yeah, so here, just again to make the point, we have actually a very nice group, visualization explorative data analysis in Jena, at the university in the computer sciences, and he gave recently a nice public talk, Kyla Vaughan, and I think this is really what I could also subscribe. I mean, purpose of visualization is insight. I think that's at least scientific visualization, and not just pictures. Of course, it's nice. It's also if it's also aesthetic, but I think the real point is that through visualization, one can get a lot of very important insight into data or links between different entities and so on and so forth. And he has also this very nice, I also once did it earlier, but he has this very nice example that is trivial, I know, but it was for me an excuse to quickly check yesterday what I learned about algebra of graphics. So let's look at that data set in Julia. So it's basically a data set of X and Y in 4 different groups. And so, and then I also, for the first time I did a notebook in Julia. So I have just put this table in CSV file. So this is kind of a data frame now with this group that I call A, B, C, and D. And then let's calculate the statistics. And that's exactly the point that he's making. If you look at that data set, you saw there were some numbers, but then, okay, people like summary statistics and so on. And then you get here the mean, exactly the same, the standard deviation. Oh, I did actually make a mistake. Okay, you have to tell me how to do it better. That X and Y get a standard deviation and mean, but okay, doesn't matter. But so basically the standard deviation, yeah, you can tell me. I remove comma after mean, then it's broadcasted in both ways. Yeah, okay, that's okay, let's do it. Yes, exactly. Yeah. So you see, I'm really learning. Okay, now it takes more time because no good. Okay, but here we are. Yeah, so you see basically the standard deviations of both variables are very similar. And then I calculated the correlations. There they are also almost the same. I mean, they should conceptually they are the same, and then the linear regression coefficient you also see that they are exactly the same. So one could say, okay, these 4 data sets seem to be really the same. And then we visualize them. My AOG one-liner. Okay, but also that takes, I don't know why it takes so much time. Okay. That's one of the, okay, here we are at least. So that's how the data set looks like. Well, very different data distributions, strange ones also. Gives the same summary statistics, but if we visualize them, we can see really how different they are. And of course, in the bivariate case, it's nice. One can visualize it, then it's more difficult if it's multivariate and so on and so forth. Okay, but that was just kind of a introductory example. And actually has a very nice other example, really historical example of life-saving example of, well, hand-drawn visualizations back in the 19th century. where this guy was basically looking at cholera outbreaks in the city, and nobody knew at that point about bacteria and so on. And so he was just trying to understand where these things happen. So he mapped out here these black bars. He really by hand mapped out on the plan of the city where most of the outbreaks were happening, and they were obviously happening in this area, and in particular very strongly here. And then he inferred that here's a well where people took water from. They closed the well, and afterwards cholera stopped. And people still didn't believe him that these were these strange bacteria. Only, I think, 30, 50 years later, it was really then clear. But it's kind of empirical. He used basically empirical and data evidence to find the origin of the disease. I think it's also a really nice example that Kai made. Yeah, but also there are examples of manipulating visualizations, because visualizations are so strong and powerful, one can use them to manipulate. And he has also quite some funny examples. You see what that is about. I mean, some of them are really blunt, or most of them actually. This one is maybe a bit more subtle. Yeah, okay, but anyway, so this is of course a big danger with visualizations. I think there's a lot of responsibility if you visualize. And here's another funny thing: choice of colors. Maybe one should reconsider some of them, and it's pretty clear. This is actually a psychological experiment, I think, to have this disconnection between the word and the color. Maybe I don't know. And then if you look at that, I mean, this is really not a very good color scale, where it's basically with increasing numbers, the colors do not increase in the same way. But these kind of things you see all the time in the newspapers, or in some popular science, or even sometimes in scientific literature. One has to say, actually, the data science and journalism has really become really much better in the last years. But anyway. Yeah, so what was, and then just some things that I closer to our research. I mean, there are certainly been successful climate visualizations, and maybe these are the two most famous ones. I don't know if you know them, but okay. On the left-hand side is just the climate stripes that have been also becoming the logo for Scientists for Future. Well, it's just the colors indicate the temperature, global temperature, and then the time is on going from left to right. And here on the right-hand side, we have the climate spiral. Basically having a bit more information, having a circular plot, and what we can then basically see here in addition, so that it's just increasing, that it's really in principle increasing every month, if you want. No? And well, and one can visualize it out in this way. That's what I did. So basically, looking from the side, and you see basically climate stripes in the vertical direction. So very nice, I think, very nice, and it has been very important for communication. No question, but I would also say, from a scientific point of view, a system scientific point of view, it also creates a conscious bias, because people concentrate on this temperature signal, which is nice to visualize because it's smooth, it's changing smoothly, but then people only think about temperature, and everything is only global warming. So is temperature the most important climate driver for ecosystems, for societies? I would say not necessarily. It's just the least noisy signal. And for example, our research shows that really the water cycle, precipitation, and these kind of things are really, really important. So just as a caveat, also here in these very nice visualizations, there is conscious bias introduced, I think. Yeah, so this is the MPI VGC version of it. Geran Pulse, together with Lazaro, I guess, also created those in this 3D. And the idea was basically to have also kind of a mirror here that one can see these trees from different perspectives. So winter and summer, you see, although it's 3D, all at the same time. Last but not least, one thing that I just looked up this morning. Of course, maps are also quite important for visualization in our field, of course. And this is actually also quite nice one because it's an integrative map of climate impacts. So it's about how land values, mostly agriculturally based, will change until the century according to a certain climate scenario. I find that quite striking. I mean, it shows who's really suffering. And this is, you know, this Eastern Germany kind of on the edge, but also, of course, there are countries and this that are actually benefiting, like the northern countries will be benefiting to some extent. Yes. So, and then now one example of from our own research. So we like to work a lot with this ecosystem data. You see here these different stations. And this is a little bit like I like the comparison actually to the medicine. So like minimal invasive observation, like the brain scans or brain EEGs, and basically what is measured with this instrument is the wind speed, the vertical wind speed, and concentration of some scalar like CO2 concentration, water concentration, but also just heat content of the air, and then more or less the product of the two, speed times concentration with the flux density. So then this is how one can basically continuously measure the fluxes between atmosphere and ecosystem. So we get this kind of time series. Exactly, it's just my reminder that I want to show another Makie thing. And okay, let's see. Yeah, I think I don't reload the data set. Let me just, I just want to make one point. So it's a time series, as I mentioned. And yeah, I don't know if is this actually a way to make it full screen? Here? Here? Where? Huh? I didn't understand, sorry. Select the image, yeah, and then? I don't select, yeah. Here? A little further to the right? Okay, I can, okay, that's a good idea. Okay, then I can do it. Okay, yeah, no, okay, then it's a bit bigger, but basically what we see here is basically 3 years. Very nice that AOG can plot times. 3 years of 3 different variables: temperature, air humidity, shortwave incoming radiation to the sun, and on the lowest plot is basically the what we would think as a response variable, the net ecosystem exchange. So it's really how much carbon the ecosystems are taking up, and negative means actually taking up. So that's the convention. So flux from the atmosphere into the ecosystem is negative, and you see, well, okay, what we see here is basically 3 seasonal cycles in this one-dimensional plot. But well, I doesn't see too much detail, and actually, I wanted to plot it actually in Makie to zoom in, but okay, I don't do it anymore now. But if you zoom in, you would see that, of course, there is higher frequency variations, the diurnal cycle, night and day and night. And what is really in the community for a while, and we've seen actually also similar plots yesterday, and it's also nothing special. Also, geographers did that for quite a while. These isoplates diagrams, but it's just an example how then one can visualize that in a better way, kind of, always showing more information. So now we have basically on the x-axis time of the day, on the y-axis time of the years, and then the colors code what is the uptake. So brown is now the uptake into the ecosystem that you see basically here then the diurnal cycle. So in the night, it's positive, release by respiration, and then it's taken up because the sun is shining, and then there's release again. But we see also then the seasonal dynamics here, it's pretty active, and then suddenly the white, not much happening. Again, not much happening in 2003 in particular. And okay, maybe this, and then one can, of course, and this is also basically again the responsibility of visualization. I mean, I this function, so I do now a little bit of, I say, let's smooth it a bit with a bit less smoother, then maybe the patterns become a little bit more visible. But one can, of course, also oversmooth it. And so that's always a question because it's then okay, then things get lost. It still looks nice, maybe, but one has to be, of course, very careful. And one thing, well, one can also say, okay, but now I want to look at actually what is the average. Okay, maybe one point. So we call them fingerprint, as you see, because they are really like fingerprint. Every ecosystem looks different, and so one can calculate this kind of fingerprint for example, this is then the average over more years, not just the 3 years, but over the whole data set. So this is kind of the characteristic annual cycle of a Mediterranean ecosystem. So it's in southern France with activity here in March and April because it's already warm and not too dry, and then it's getting too dry in summer where you have the white spot. So that's basically the average of each half hour across all years, no? Or here, then I can calculate this is basically the standard deviation of each half hour flux across the years. And so here we see actually the pattern is a bit different. So it does not just scale with the mean, but we have a lot of variability than in autumn. Because probably it depends when the rain is coming back and so on. So this was my short excursion into this. And yeah, okay, these were my old R fingerprints. And I selected those because basically on public talk, these things really cling to the people. They understand, okay, ecosystem are different and they're doing something and so on. So this is quite nice. And we basically see intuitively tropical rainforest is active all year. European beech forest has this very sharp start. It will start in a couple of days when the leaves come out, and then suddenly they are active. You see also they have the same activity as a tropical forest in summer. They're just not active all year long. And then the Mediterranean forest that I just showed before. And then just the thing, we want to go global. So we have all these different observation stations, and so we need to somehow combine this with remote sensing data, so to get a global picture. This is a bit the idea. This is now not about so much about visualization, but just quickly, we basically use information of both the data streams, the local ones, and then the ones that are globally observed, and use information at the intersection of these two scales, and do some machine learning regression methods to then be able to map these remote sensing data onto the exact measured fluxes, because these fluxes cannot be observed directly with remote sensing, right? And then we can apply this model, this regression model, very globally using the globally available remote sensing and meteorological data. And then, okay, where is the other? Okay, I don't know what I did. Okay, let's see. So then, yeah, we get basically, yeah, okay, let me be a bit faster. Interesting thing, for example, what we can get is, for example, we plot here the chemical energy that is very embedded in the shores by photosynthesis against the radiation energy. And we see what is the radiation use efficiency of the vegetation. And you see it's much lower than 1%. It's compared to photovoltaics, which is now really above 10%. It's already, for me, a clear visual depiction of that bioenergy is not the solution of our energy problem. So then, this is my plot in Makie, basically showing this animation of how the biosphere is kind of breathing. I did that before in R, and then I thought, can I do it in Julia also? And it's really nice because it's 30 times faster the rendering than I could do it in R. So very nice. And then then I also, okay, one can also do it on an equal area or on a map, and quickly maybe. So here this is more a diurnal. It's supposed to be a diurnal cycle. So where you basically see where the sun kind of is moving, if you want, and then when it's day, you just take up carbon. This is that long map, and this is a equal area projection. Also something important for visualization, because this one doesn't reflect the right sizes of the continent. Africa is too small, Greenland is too big, for example, and Northern Europe is too big. And here we have the Robinson, and that's rather that's still I do it. How I do it is R macro, because I don't manage to reproject things well in Julia. So this is my problem, and I guess I'm a bit over time. So I stop here, but there's another complaint, and I didn't manage to really write a wish list, but I think it would be really good to have more high-level functions that users can use. AOG is really great. And here, for example, I have a scatter of some data. I leave out the live example, and this is, and I want to create a surface that fits the scatter. I still do it with R, with Verse 2D. I don't know how to do it in Julia, and I think it's probably not easy. So these kind of things would be really nice. Of course, it can be worked on, and of course, re-implementing something is also boring, I guess. But yeah, this is a short wish list. Okay, thanks.
So any comments, questions?